Welcome to solverfy.
Okay, in this problem we have two polar coordinates. The first one is 2.5 meters at an angle of 30 degrees measured from the positive x-axis. And the second one has a distance of 3.8 meters at an angle of 120 degrees. And the first question is, what are the Cartesian coordinates of these 2 points? So if we look at this first point right here and we think about it as a right triangle, we can see that the x value is going to be 2.5 times the cosine, because we're dealing with the adjacent of 30 degrees, and the y is going to be 2.5 times the sine of 30 degrees. And when we plug these into our calculator, we get 2.17 meters and 1.25 meters for the Cartesian coordinates of those 2 points. So we can write that down right here, 2.17 meters and 1.25 meters for the first point. For the second point, we do very, very similar. We've got 3.8 times the cosine of 120 degrees. And the advantage of using this as opposed to just trying to make it a small triangle is this will give us the minus sign that we need, and we don't have to think about it. And so when we do that math, that's minus 1.9 meters. And when we calculate the y value, which is this right here, that's going to be 3.8 times the sine of 120 degrees. And when we use our calculators, that's 3.29 meters. And so that gives us a Cartesian coordinate of minus 1.9 meters and 3.29 meters. And we can draw a nice box around those 2 answers. And those are our Cartesian coordinates. Now the second part of the question is asking what's the distance between the 2 points. Now if you recognize this as a 90-degree triangle, which doesn't always happen, you could just easily do the Pythagoras theorem on 2.5 and 3.8 and get the answer very quickly. But I want to go ahead and just press forward with the vectors and see how we do this vectorially. In order to find this distance, we need to find the x, and then we need to find the y. And the x is just going to be the difference between these 2 points. And so our x displacement is going to be 2.17 minus 1.9. So we add it, and that gives us a 4.07. The y value is going to be 1.25 minus 3.29, which is minus 2.04. These are in meters. And then all we have to do is use Pythagoras. The distance then is 4.07 squared plus minus 2.04 squared. And then we take the square root of the whole thing, and we get a total distance of 4.55 meters. And that's how you do it. Thank you.